Alright, so today we're going to discuss laws of exponents as a quick recap for integral exponents topic. So when we say integral exponents, that means, well, it means two things. First, it's integral. Second, it's an exponent. So what does integral means? Integral, it means that the exponent is an integer. So integer means it's a whole number, so it can be a negative number, zero, or a positive number. Exponents, these are the small number on the top right side of a bigger number or a variable. For example, 3 squared, this is the exponent 2, and then x cubed, this is the exponent 3. So there are different laws of exponents. Let's start with 0. So the law for the zero exponent, any number that is not equal to 0 when raised to 0 will be equal to 1. What if it's equals to 0? That's going to be undefined. So even though no matter what numbers we have, like 2 raised to 0, 109, 1999 raised to 0, these are both equal to 1. But be careful about this when, for example, we have negative 5 raised to 0. When it's written like this, we treat negative like as a separate value, like as negative 1 times 5. So at this case, only 5 is right beside 0. So that means only 5 raised to 0 will be equal to 1. So it would be like this, or simply negative 1. But then, if it's inside a parenthesis like that means this entire thing is being raised to 0, which will make it just 1. Because anything, whatever this value is, will be 0. Same with a variable, for example, we have 2x raised to 0. That means only x raised to 0 will be 1. So this is going to be 2 times 1, which is 2. But if you put it inside a parenthesis, that means this entire thing is being raised to 0, which will give us the same answer 1. And then down to positive exponents, or like the general rule for the general laws of exponents, we have the very first one. So this is the law to add exponents. When do we do this exactly? So we add exponents when we're multiplying same bases. What do we mean by base? This is the value or the number, like the bigger number or value beside the exponent, like 5 squared. So this is the base. If you're going to multiply that to same base, which is 5, but different exponent, then all you need to do is copy the base and then add the exponent, which will give us 5 raised to 5. Then you just solve for that. You just multiply 5 times 5 times 5 times 5 times 5. And it applies the same thing for variables like x squared times x squared. That's simply x 2 plus 2, which is x raised to 4. And then I believe that's pretty much it. So if we have something like this, x squared y cubed multiplied to xy. So for this, all you need to do, since they're all being multiplied, all you need to do is combine the same bases. So x, we have two exponent here, and when you're not seeing an exponent at the top, that means the exponent is just 1. So 2 plus 1, and then y 3 plus 1, which is equals to x cubed y raised to 4. And then the second is the so odd exponent, and then the next one would be this multiply exponents. Or for me to, remember it more easily, I say inside times outside exponent. When does this happen? Like for example, you have x raised to 2 and then raised to 3. So x raised to 2, that means you just have two x's. So that's one group. But then you're gonna raise it to 3. That means we need 3 of these with two x's each. So that's how that works. And then you count the x's, we have 1, 2, 3, 4, 5, 6 in total. And when you add this, 2 times 3, I mean you multiply, then that's x raised to 6, which is basically the same as this. Next, we have the third rule, which is distribute. Distribute to the factors. So to distribute to the factors, here's what you need to do. For example, you have 2xy raised to 3. So that means if the entire thing inside the parenthesis is being raised to 3, that means you'll have to give 3 as an exponent to each of those values inside. So we give 2, we give x, and we give y. And then you just need to simplify that, like 2 times 2 times 2, that's going to be 8, x cubed, y cubed. But what if there are also exponents inside? So let's say 2x squared y cubed raised to 3. Then you just distribute it as well. So 2 cubed x squared 3 y cubed 3. And then just multiply following the second rule, which is multiplying the exponents. So 8, 2 times 3, that's going to be 6. And 3 times 3, that's going to be 9. Or you can just multiply directly. 2 cubed, 2 times 3, 6, 3 times 3, 9. So whichever works for you, if it works better writing this, then that's totally fine. And then we have the fourth rule, which is subtract exponents. And these happens when we're dividing. For example, we have x raised to 4 over x raised to 2. So if we have the same bases on top and at the bottom, like numerator and denominator, just subtract their exponents and you'll get your answer. What if we have multiple values? Like for example, 4, x raised to 5, y raised to 3, 2x squared y. Then just separate them first. So 4 over 2 times x raised to 5 x squared times y cubed y. And then 4 divided by 2 is 2. 5 minus 2 is 3. 3 minus 1 is 2. But what if the numerical values cannot be divided by each other? For example, we have, let's say, 12 and 8. Let me just write the authors too. So if they cannot be divided directly, then we can find their greatest common factor. So first is divide directly, then second is GCF. So think of a common factor, greatest common factor of 12 and 8, that would be 4. So you may want to divide both of them by 4. 12 divided by 4 is 3, 8 divided by 4 is 2. And then just solve everything else. And that would be your answer. What if they don't have a GCF? They cannot be divided. They also don't have a GCF. Like let's say 2 and 3. Well, just leave it as is. So if they cannot be divided, no GCF as well, just keep it where they at. So this is going to be 4 minus 2. And there you go. And lastly, the fifth law would be distribute as well, but this time for the numerator and the denominator. For example, you have x, x over y raised to 5. Then you must distribute that to both numerator and denominator. All right. And then we have the negative exponents. So how do we deal exactly with negative exponents? So negative exponents, for example, we have x raised to negative 2. Our goal is to get rid of that negative in this exponent. And to do that, all we need to do is get its reciprocal. Like for this one, so reciprocal, if you can't recall, for example, we have 2 over 3. The reciprocal of that is 3 over 2. Just, flip it. So x raised to negative 2. But how do we know it's reciprocal? It's just a whole number. It doesn't have a denominator. Okay, so what you need to do here is put a 1 here. Okay, so what is the reciprocal of this value alone? Then that's going to be 1 over x squared. So I put an imaginary over 1 here for every whole number. Like if it doesn't have a denominator, technically speaking, its denominator is 1. We just don't put it because it won't make any difference. But here it will definitely make a difference. So if it's the other way around, like for example, we have 1 over x raised to negative 2, then we do the opposite thing. So that's going to be x squared. But what if there are other values? For example, we have 2x raised to negative 3. We only get the reciprocal of this x raised to negative 3. So the reciprocal of x raised to negative 3 is 1 over x raised to 3 or x cubed times 1. So 2 times 1 is 2 and then x cubed. So basically, you just put it on the other side. That's like the shortcut. So if it has a negative exponent, then you just put it on the other side. If it's on the top, you put it to the bottom. If it's at the bottom, you put it on the top. And another example, if we have, okay. So for this one, it's the same thing. It has other values both in the numerator and denominator. So we're just gonna get x raised to negative 3. So instead of multiplying it by the reciprocal, going all through that process, you can just move it to the top and we'll get the same thing. So 2x cubed y over 3. So it's like we multiply 2y over 3 times 1 over x cubed, just like this one. And that is your answer. In cases where they're in, like they have both negative numbers and they're the only values, then you can just switch them. So x cubed, y squared. There you go. And if the entire thing, like x over y, is being raised to a negative exponent, like negative 2, well, technically, you can distribute this, like it will be x raised to negative 2, y raised to negative 2, then we'll have to switch them, but it won't be, as simple as this all the time. So what you can do is you can just switch them beforehand, before even distributing this. So y over x squared. And then you can simplify y squared over x squared.